How are you?
I'm great. Thanks, Eric, for
Good.
having me here.
Of course, of course. I want to start with a question to the audience first, if you don't mind. How many of you have your own AI agent? How many of you have an agent working for you? Yeah, half of the room, right? How many of you trust that AI agent? You do? You do? Okay. Not everybody, right? That's interesting. We're going to talk about that today. We're going to talk about AI and trust, and how do you move towards that world where AI is everywhere, and how do we continue, for some of you, to trust those agents, or how do we move to a world where we can trust those agents? So before we do that, Jonathan, do a quick introduction and tell us why did you decide to work on EQTY Lab?
Great. Well, thanks, Eric. So I'm Jonathan, and I founded EQTY Lab after spending 3 years before that at the Center for Blockchain Research at Stanford, working with some of the best cryptographers that are trying to deploy complicated algorithms that ultimately are solving this question of trust. And we formed EQTY with a conviction that there was a need for every AI model, and then eventually every AI agent, to have a form of a certificate that can present in milliseconds extensive and tamper-proof evidence of why and how it could be trusted. And if you could do that, then imagine what type of collaboration and value that you could exchange. And while I think a lot of people here are talking about scaling AI because they're looking at really the mechanics of the infrastructure or maybe the efficiency of the technology, if you speak to a business, the biggest barrier to scaling AI is not cost, it's not complexity, it's trust. I'm not going to delegate complicated mission-critical tasks unless I know exactly how to trust that agent. And just in the way that AI has evolved our concept of intelligence, it's also requiring us to evolve our understanding of trust, how we trust, and the method of that. So, and Eric, tell us about you. This is meant to be interactive here. So I've known Eric for years. He's someone I greatly admire as a leader in the blockchain space, but tell us about your background.
Well, I mean, some of you can notice I was born here, but I moved to the US 20 years ago. I have to tell you, though, I was listening to some of the politicians earlier today, I think in the room over there, and I had the feeling that I should come back now because I think there is a new wave of activity in Europe and it's exciting again. So maybe I will, but been in the US for 20 years, worked for Deloitte, worked for IBM, started my own company in between, and then now I'm running a company called Hashgraph, which is a team behind Hedera. Some of you might know HBAR, which is a cryptocurrency associated with Hedera. And Hedera is very focused on the enterprise market. So we build blockchain solutions in supply chain, in financial markets, tokenization, stablecoins, really not in the retail space or just a tiny bit. So that's who we are. We are sometimes referred to as the adults in the room when it comes to blockchain. And the reason we wanted to partner with you is because we had that notion that stablecoin was probably the first killer app for blockchain, and we believe that AI is the next one. Exactly in the context that you described, which is how do you think about AI and blockchain providing value? And I think of it in 3 different layers, right? And maybe I'll share that quickly. The first layer is when you build AI solutions, we need to make sure that those AI platforms and infrastructure are somehow decentralized. Because if we put everything into one company, one egg, in one basket, we take the risk of that company controlling the future of what you do with AI. Right? So that's the first layer. The second layer is we need to provide the trust layer to the AI system. So, and you'll talk about that more, so I'll skip that. And then the last one is AI agents, right? I mentioned agents at the beginning. When you have an agent working for you, that agent has to be trusted by you and trusted by the parties you're going to engage with, right? See, if you say, my agent needs to pay someone else, My agent needs to acquire an asset. My agent needs to do something exchanging value. You need the trust layer. Because if you don't, you really don't know what's going to happen with this agent. So those are the things we think about every day at Hedera when we are building solutions with companies like Jonathan. So that's my background and what I think about when I wake up in the morning. So tell us more about your ecosystem, because you've done amazing things with big players. And how do you go to market today?
So we partnered with Hedera actually several years ago when we understood that we needed to fine-tune models and understand how you could get the ingredients of all the data and all the code that was going into a model and provide, think of it almost like kind of a family tree. How do we understand the lineage of how we got to this point with the model? Now, if you think about it, creating cryptographic trust of this kind is actually very complicated because it provides essentially a tax. Like you actually have to do a certain amount of computation in order to create a hash and a signature. And with high performance compute, which AI is like the highest, you want to make sure that that tax is as low as possible, but that you have as strong of a seal on that proof as you can, because you don't want anyone to tamper with it. In other words, when you have that certificate, you want to make sure that it is something that is persistent, where you have a seal that is so strong that even in 10 years from now, I can say, you know what, I know exactly how that agent was trained, or I know exactly what data was used when it was put into an AI pipeline. And that took a lot of research. We came out of that intensive work at Stanford, and we formed the company with a couple of interesting insights. The first is that the Web3 ecosystem had actually pretty much solved this question around data governance. We know how to represent data, we know how to distribute data, and we know how to look at it as like the lineage of how data is transformed. That's actually fairly well established. But the question around compute has been unsolved, which is that how is it that you can put massive amounts of data into GPUs and know exactly what code was run, what data was put into there, and on the other end, you need to know that you have this authentic algorithm, or for that matter, an AI agent. And the breakthrough that we had is that we took the most complicated cryptographic proof as our model, which is a zero-knowledge proof. And if you know anything about these, they're actually computationally very expensive. And we worked with Intel and NVIDIA, and we found a way that in the processor itself, we used a new generation of hardware called the Secure Enclave that's now available on both the CPU and the GPU. And the way I like to think about it is like this. Imagine for a minute that you have a computer that's inside of a safe, and the only way to switch on the computer is that you have to have the safe that's locked. Okay, cool. So now I have an environment. I know exactly what's gone in there. And we include, before that door is shut, a notary that's able to stamp everything that goes in there. It knows what data is there, what code is there, every GPU cycle of it. And then on the other end, it provides me a notarized certificate to say, here's what happened inside of that protected environment. Now, that was only possible when Intel and NVIDIA got together and released that solution in 2023. You guys were early in seeing the promise of that, and we created this new root of trust in the processor, and then we released it. It took a while to actually get the prototypes going, to convince Intel and NVIDIA what they had on their hands, which is the superpower. And then we released the white paper in December of last year. And since then, it's been like a rocket, because the demand for this is insatiable, because people know that they actually need this type of proof. And now we have a way to give you a sense how much faster it is. We recently were working on prototypes on Blackwell, and it's 400,000 times faster to do this type of cryptographic proof with the solution that we've created, which really means it's ready for enterprise. And so that's where we got excited to have that breakthrough, and now to be able to extend that into mission-critical workflows across the life sciences, public sector, and with finance as well.
Actually, so it's way more than a white paper now. You actually have a demo that you wanted to show us. So I think we can play the video in the back. I don't know if they can hear me, and play the video. And you can comment on the video.
Okay, so I'll give a little narration here.
Yeah.
Okay.
It's real.
So this is a deployment that we did actually with Accenture, and the idea was we deployed 11 AI agents, move over, and we had requirements to, for instance, protect PII under the basically Privacy Shield, which is a California law that's like GDPR. And what you can see is that I actually cannot run this workflow here. And the reason why is because we haven't provided the right human interventions and the right tests. But once we do, and in this case here, I'll show you a human in the loop, the processor then becomes unblocked. I'm going to grant the authorization, and now I can go ahead and I can run this. And so we have 11 agents, they're all running, and they have that notary that's on the inside, and it's stamping literally everything that is going on here, and on the other end, I get this proof of exactly what happened. Now here's the most important thing. Hopefully it will just stop. I can show not only the activity, I can get a summary, which by the way is also written by an agent, but I can also show the controls that were passed and the policies that were implemented, so that as I have my own company policies, I may have regulatory frameworks, we can show that, in fact, this was aligned. And I have proof that this outcome came from these 11 agents. I have proof that they were aligned with various policies, whether they're for efficiency or for addressing questions of liability. Now that certificate there is hardened by the unique power of these next generation processors, and then it's registered. And this is where you get the blockchain component. We take that certificate and we put it on, in this case, the Hedera blockchain, because we need a way to be able to preserve the certificate, and then with smart contracting, we can start to action things like, for instance, payments or licensing, access control for data. I mean, you just name it. And all of that uses the cryptography as a seamless flow of how to be able to create trust. And most of you today use actually a very similar type of construct of trust with your SSL certificate, right, that you have in your browser. When I go today to my bank, I know that I'm going to, let's say, Bank of America and not some sort of hacker's bank, because there's a certificate which is exchanged between the bank and my browser, and the browser shows like a lock icon that says, you're good, this is going to the bank that is the expected one. Now that similar type of certificate is essentially what we have created. But the difference is, it's not about a destination, right? The web is changing before our eyes, and now agents, they don't have to live at agent.com, right? They can be deployed anywhere. And in fact, they're going to work together, and in milliseconds, they're going to do all of this activity, and then maybe they'll never work together again, right? But we need a similar kind of trust. And if for those of you who lived through the rise of e-commerce and the web, we needed those types of mechanisms of trust in order to be able to put down our credit card or to decide to do online banking. That was not something, if you lived through it, that you can take for granted because it took time. And those certificates are now ubiquitous. We're doing the same thing. And as I said before, until you have a system like that, how do you know that your activity is confidential? How do you know that your activity is governed correctly? Those are the questions that we're answering, and it's real.
And it's real. I mean, that's the big thing that I was very excited about when I saw that the first time. Because for you it's real, for us it's real too. I'll give you an example of what I heard today, and it was something I never thought of before. I actually thought of it 2 weeks ago. But the idea is, today when you do marketing campaigns, you do marketing campaigns to humans, right? You go on social media and blah, blah, blah. And the guy was telling me, you're getting it wrong. You need to do marketing campaigns to AI agents now, right? Because AI agents are going to be way more in population than the actual humans, and they're going to make a lot of decisions. So you need to market to them what you want the world to know. So you have to design your marketing campaign around that. And in
search engine optimization is now...
It's a LLMO optimization or AI agent optimization, right? So we were talking about all of this, and I was thinking, well, how do I know that my marketing campaign is actually working, right? And using a technology that we just talked about would help me add that level of trust. So now I know that my message was read by AI agents, consumed by them, and maybe used when they are answering a question, right? What is the best blockchain in the world? I want them to say, it's Hedera, right? But how do I know that's happening? And even today in Web 2, you don't do that. But in Web 3, with that technology, we could get guaranteed that the activities that we are expected from a marketing campaign are actually taking place.
Yeah, it's a great point. And let me give you a sense of scale, because I think that's an important kind of corollary to what Eric's talking about. Last year was the first time in human history in which there was more activity of AI or non-humans on the web than humans. It flipped. It's an inflection point. And that will not go back, from our sense. And it's going to skyrocket. And if you think about the problems with like spam in your email that we had to overcome, now imagine a world in which Jensen has painted this out. In every division of NVIDIA, he expects that there will be 100 million agents in every division of NVIDIA. And there's obviously more than one. Okay, so that's the scale of the problem. We're talking about trillions of agents that are online. That's going to mean about 120% compound annual growth in network activity. It's going to fundamentally switch the networks. It's going to mean that they're going to have, about 2,000 exabytes worth of activity that's going to be on those networks in short order. And then, of course, if you walk down the aisle over there, that's just virtual agents. Now you're going to get into physical AI. That's a $7 trillion humanoid market that's just taking off right now. That's expected to be in 37% of all homes by 2050. All homes, not just some, all. So that is an extraordinary reconfiguration of how we're weaving AI into our lives. And the question is going to be whether or not how do you establish trust to deal with this level of problem? And our argument is that the idea of like deep packet inspection or the ways in which firewalls or spam work today is that they take their best guess as to what should be trusted. And we said that's just not going to work. You're going to need a lightweight certificate that's going to provide the highest level of proof that my agent is what I say it is, that it's been delegated proper authority, it's been trained correctly, guardrails are in place. And if it doesn't have that certificate, it should not get access to resources. In fact, there's a world in which it doesn't even get access to move on the internet. We're thinking about that so the sovereign guarantees, which is what you're going to kind of hear around here, they're very relevant because ultimately they're going to be kind of like the right of way or the ability for agents to act. They're going to need to present that type of passport, right, to be let into the country to prove that it can essentially, follow the laws and can be trusted. And it's not a rogue agent. It's not an agent with advancing mis and disinformation, et cetera. So, Eric, I think we're kind of wrapping up.
Yeah.
What are the things?
I didn't bring my AI agent to tell us whether we are out of time or not, but we are out of time. Okay, so we need to close here. Thank you very much, everybody. Thank you, Jonathan. If you have any questions, we're going to stick around for a little bit, so please. Thank you.
Pleasure.